Hello everyone. So now let's try to understand the optimal approach to solve the prime number problem. Okay. So in previous lecture we have seen, let's say there is a number n equal to 36. So how we can find the divisors for 36? So basically we can find it, right? 1, 2 is also a divisor, 1 is divisor, that means 36 also divisor, right? It is nothing but n by I, which is nothing but 36 by 1 is not equal to 36, so it's also a divisor. Then 2, that means 18 is divisor, nothing but 36 by 2. Then 3, yes, 3 is a divisor, so that means 12. Then 4 is a divisor, right? 4, that means 4 is also a divisor, right? So you can say 9. Then 5 is not a divisor, then 6 is 6. So basically 36 by 6 is nothing but 6. And then we understood the logic to avoid this 36 and this 36 from the divisors problem, right? So it's nothing but if you try to find till 6, you will anyway get all these numbers after that: 9, 12, 18 and 36, right? So why till 6? We have seen this. So it is nothing but square root of n square root of 36 equal to 6. So till 6 we will try to find out the problem. So how we can use this particular logic here? Maybe we can run loop till square root of n, right? If square root of n, if we find 1, that means we have one more divisor for that particular number. So we can optimize it by running a loop till root n. Root n is nothing but we can use it in Java using maths function, math.sqrt of n, right? So in this case what will happen? It is accepted, right? We can try to submit it also. Few cases are failing. Why failing? Let me just see. Why few cases are failing in this particular scenario? N modulo I equal to, we are returning false here. We have taken care of 1 also, right? And if we don't use n, then in that case what is happening? Let's see. Maybe this is also not submitting correctly. Is it? No, it's accepted. In case of this, it is accepted because we are running till n, right? But in case of root n, like math dot square root of n, it's not accepting because let's take one counter, maybe int counter. Let's take int counter equal to 0. Okay, so here what we'll do, we will do counter equal to counter plus equal to 1. Okay, then again we will check for one condition. You remember we used to avoid one number, right? 6. So we don't have to consider 6 again, right? So how we used to avoid? So we used to avoid n by I. N by I is not equal to I, right? N by I is not equal to I, then in that case we were not including that counter. So here what we'll do, if n by I is not equal to I, then in that case only we will increase the counter. In this particular case, counter plus 1. Okay, and what we'll do, if counter equal to 1, counter equal to 2, then return false. Counter equal to 2, then return true, sorry. In this case 2 divisors only, and else return false. Return true and return false. Okay, and we will run our loop from 1 to less than equal to 1. Okay, let's try to execute this. It's accepted. Yes, it's submitted now. And talking about the space complexity here, it is nothing but O of 1, because we are not using any other space, and time complexity is O of square root of n, because we are running loop till square root of n, right? This is our code, right? We are running loop till square root of n, so our time complexity is O of square root of n here in this particular case. So yeah, thank you for watching.